Okay, so we're still looking at our linear and rational equations, and more specifically the rational equations. Remember, rational means fraction, so we're trying to figure out what's going to happen when you have a fraction and specifically a variable in the denominator. How do you get rid of that? Well, we've looked at a couple of the easy ones where you just simply multiply everything by that LCD, but sometimes the LCD isn't going to be so easy. It's not going to be standing right in front of you. The ones that we saw in the past, it was just right there before your eyes. But let's take a look at one where it is not right there before your eyes. Let's say we've got 2 over m plus 4 plus 5 over an m squared minus 16 equals a 1 over m minus 4. Now see, in this case, that LCD is not sitting right in front of me. It's going to be difficult for me to figure out what I need to multiply everything by. But kind of like when we were adding and subtracting our rational expressions, not equations, expressions. Remember when we said that in order to add our fractions, we need to have those common denominators, and when they were rational expressions, the denominators were a little bit difficult. When the denominators looked kind of like this, we said, well, to get the LCD, we would need to factor this one, and then we would need to multiply by whatever we need to create the LCD. So let's try to factor this one and see what happens with that. Now this one's in good shape, so I'm going to leave it alone. But this one, if I factor it, it's a difference of squares, and the way that you factor a difference of squares is that you factor them as, loosely said, conjugates. So it'll be an m plus 4 times an m minus 4. And so now what I've created is something that's a little bit more easy for me to see. In other words, as I look at all these denominators, I go, now hold on. If I took this one and multiplied it by an m minus 4, it would look just like this denominator. And if I took this one and multiplied it by an m plus 4, this one would look just like that denominator. So that's what I'm going to do. I'm going to take this one over here, and I'm going to multiply this denominator by an m minus 4. Because now that one looks just like this one. I have that LCD. I have that common denominator now. But recall that I don't want to change the value of this fraction, only the looks. So whatever I multiply on the denominator, I have to multiply on my numerator. And now, as I look at this one, I say, well, if I would take this and multiply it by an m plus 4, now that denominator looks just like these. But once again, whatever I multiply on the denominator, I have to multiply on my numerator so that I don't change the value of the fraction, only the looks. But now that's exactly what I've done. So what I can do is I can multiply on these numerators, because remember that in order to add and subtract fractions, in order to add and subtract rational expressions, I need to have those numerators in a way that I can combine them up, and I can combine up all the like terms. Now that all those denominators are the same, what I can do is I can just combine up the numerators. So here I'm going to keep the denominator, and I'm going to combine up these numerators. Well, a negative 8 plus a 5 is a negative 3, so I have a 2m minus 3. And notice, very much like the first time that I showed you what happens with your rational equations, now my denominators are the same, and it's saying that this entire fraction is the same as this entire fraction. And so if the denominators are the same and the fractions are the same, that means the numerators have to be the same. So in other words, that means that the 2m minus 3 has to be an m plus 4. And now we're down to a very simple equation that I know how to solve. Once again, all I got to do is get all my m's on one side. I'm going to subtract this m over, and then get all my constants on the other side, giving me that m equals 7. Now, once again, check that extraneous root. But as I check the extraneous root, and I come back here to the beginning, Here, what would create a 0 in the denominator is if m was a -4, so it can't be a -4. Here, what would create an extraneous root would be if m was a +4. And here, in either case, -4 or +4 would create the extraneous root. So m cannot be a -4 or +4, but we figured out that m was going to be a 7, so this 7 is going to be okay. That solution is just fine. But now, the catch is, once again, like with the other rational equations, there was a shortcut. That before we took all of our equations and we simply multiplied them by the LCD. Go back to one of the first ones that I showed you, this one right here. We took the whole equation and we multiplied it by an LCD because it canceled out all the fractions and gave us a simple equation. We'll wonder if we can do the very same thing with the complicated ones like this. Well, let's give that a shot. So let's take the equation we had started with. And let's say, okay, let's multiply the whole thing by that LCD. Now remember, the LCD that we had gotten was right down here. Every one of these, that common denominator, was the m-4 times the m+4. So I'm going to multiply the whole thing by that LCD of m-4 times m+4. So that means I'm going to take this one and multiply it by that common denominator of m-4 times m+4. I'm going to take this one, do the very same thing. Every single term. Multiply it by that LCD. And I'm going to take the back, the right side of the equal sign, and do the same thing, multiply it by the LCD. Because what happens is, notice that now my m+4s are going to cancel, and I'm just left with an m-4 times a 2. Some of my markers are going crazy. Here, notice that an m-4 times an m+4 is the m squared minus 16. If I would factor this out, I would get an m-4 times an m+4. And so now the entire denominator will cancel out. And so I'm just left with a +5. And on this side, my m-4 will cancel out with that m-4. And I'm just left with, on this side, an m+4. So once again, I'm down to a very basic equation that's easy to solve. Just not easy to look at because the pens are going crazy. But in order to solve it, I distribute my 2 through. So I have a 2m minus 8 plus 5, and on this side an m+4. And now, once again, this is easy to solve. All I have to do is combine up the like terms. So a -8 plus a 5 will give me a -3. Now let's get all the variables on one side. I'm going to subtract my m, and I'm going to add my 3. Because see, that took it right back to the same equation we had before. Notice in red, once we had gotten the common fractions, the same fractions, and said the denominators are the same, so the numerators have to be the same. That's what's in red here, and that's what's in purple right here, the very same equation. So like I said, the trick is, just like before, that if you don't like the fractions, all you have to do is multiply every single thing by the LCD. It's just to find the LCD, sometimes you're going to have to do a little bit of factoring to figure out what the LCD is. So I'm going to insert that little piece of the puzzle right up in here in the notes, that sometimes you must factor first to get the LCD. Alright, so let's try another one. Let's say that this time I have a 6 over an x plus 3 minus a 5 over an x minus 2. And that's going to equal a negative 20 over an x squared plus x minus 6. And I'm looking at this and I'm saying, okay, they've got fractions. They've got, if I could multiply everything by the LCD, that would get rid of those denominators. It would be a very easy equation to solve, but I'm just not sure what the LCD is. But I look at this denominator here and I say, well, if I could factor it, maybe that would lead me to the LCD. Well, this denominator factors as an x plus 3 times an x minus 2, which is pretty handy because now I look at the whole thing and I say, well, if I would multiply everything by this LCD, that would completely cancel out this denominator. It would cancel out this much, and it would cancel out that much. So I'm going to take the entire equation, I'm going to take every single term, and I'm going to multiply every term by that LCD. Every single term by the LCD. Now I'm running out of room, so I'm going to drag this one down here into the next line. Which really, this is just an x plus 3 times an x minus 2. And I'm going to take that entire term and multiply it by an x plus 3 times x minus 2. Because now what happens is, notice that the x plus 3's cancel out completely. The x minus 2's cancel out completely. So on this side of that equals sign, all I'm really left with is a negative 20. The denominator canceled out all of that. Now over here, the x plus 3 cancels out with the x plus 3, and I get a 6 times an x minus 2. Here, the x minus 2 cancels out with the x minus 2, and I get a negative 5 times an x plus 3. This is a very simple equation to solve because all I have to do to solve that one is distribute my 6 through, distribute my 5 through, combine up my like terms. 6x minus 5x is x, negative 12 minus 15 is a negative 27. Super easy to solve. I'm going to add a 27 to both sides. That tells me that x is going to be a 7. Once again, a 7. But remember, I just need to check and make sure, is that an extraneous root? So as I go back and I look at the denominators that are here, extraneous roots, well, if x was a negative 3, that would cause a problem, so x can't be a negative 3. If x was a 2, that would cause a problem because that would create a 0 in the denominator, so x cannot be a 3 and it cannot be a negative 3 or a 2, but I said x needed to be a 7. So that's going to be my solution.